Let's start with a brief introduction about the study of movement. The movement can be studied by two different points of view, kinematics and dynamics. When we talk about kinematics, we are going to evaluate how the joint angles change in the time during the movement. When we take in consideration the kinetics, we are going to assess the force exchange between the subject and the ground during the contact phases of the movement. During this webinar, we are focusing on the dynamics in order to introduce you the new BTS P6000 system, the most innovative force platform on the market for the dynamic evaluation of the movement. BTS P6000 has not to be thought as a single platform, like you are used to think. But BTS P6000 was born to be a modular sensory floor that through its surface is able to measure the ground reaction forces generated by a subject standing on or moving across it, allowing a complete analysis of the static or dynamic postural condition. Unlike the normal force plates that you surely know, the BTS P6000 has been developed changing the position of the connecting cable from the lateral side to the under part of the platform, keeping all four lateral sides completely free. In this way, the modules can be placed perfectly one adjacent to the others, along all four sides at the same time, without space among them, so that finally it's possible to create a real sensorized floor, any size large. The subject can move freely, so that any contact to the floor is used for the dynamic analysis of movement. This particular architecture allows to measure the components of the ground reaction force in all the available length of the sensorized surface without any discontinuity. All the foot contacts across two adjacent modules that produce two different force contributions can be merged together in order to have only one global force resultant. BTS P6000 is a highly reliable, accurate and versatile system, and it is able to replace all the other traditional analog platforms because it's completely digital. Each module is able to process the data directly on board without using an external analog digital device, and it's equipped with 12 sensors that break the force into its different components. The connection among the single modules that form the sensorized surface is made by Ethernet LAN cables that ensure a higher accuracy of the data respect to the normal analog platforms. BTS P6000 shows also an improved design of the supporting pins for the arrangement of the platform on the floor. The new shape with a spherical base of the supporting pins allows a more consistent distribution of the load on the underlying points of contact. In this way, the platform can be better adapted to the floor, increasing further the precision of the measure and reducing the crosstalk in all force components. The high precision of the measure in each point of the platform surface and the increased performance in dynamic condition lead the platform to become the perfect instrument both in clinical and sport field. In the clinical world, the BTS P6000 system is mainly integrated into the motion analysis laboratory for the gait assessment in order to know the level of functional limitation of the patient. to follow the evolution of motion disease due to the pathology and to check the efficiency of all treatments applied to the patient to improve the movement. By adding optional video cameras, it's possible to use the BTS P6000 system also in a standalone configuration for the gait analysis, thanks to the BTS DIGIVEC solution. The BTS P6000 platform combined to the BTS Vista cameras provides an increased reality system for a real-time analysis of movement and posture. Starting from the data acquired by the first platform, it's possible to display the ground reaction vector superimposed on the video of the subject during the test. The superimposition of the force vector directly on the video gives us a very intuitive solution for the evaluation of the dynamic patient's behavior. Thanks to the real-time analysis of the platform data that allows us to understand the action of the reaction force, BTS DigiVec becomes a necessary tool for the rehabilitation centers in order to prevent or limit the joint overload, to evaluate the quality and the efficacy of orthosis, prosthesis, shoes, and so on. In addition to the real-time analysis, the walking evaluation is supported also by some specific protocols for the data processing that provide important and intuitive indexes for an immediate clinical overview of the patient. In this example, it's very simple to understand that the patient has a good walking because the force profile score index for both right and left side is exactly inside the normal range. It's possible also to evaluate the pattern of each force component and compare it to the normal band. The anterior-posterior component is characterized by a first negative phase and a second positive phase. Because it is linked to the body mass acceleration on the walking progression plane, during the first part of the stance phase, the body is decelerating, and in the second part of the stance phase, it is accelerating. The medial lateral component is generally small. During the single support phase on one limb, the ground reaction force generates a body mass acceleration towards the opposite side. For this reason, during almost the whole stance phase, the medial lateral force component is always directed medially. The vertical component is characterized by a double bump. It has to be related to the reference line of the body weight. When the force exceeds the body weight line, the body mass is accelerating, and it happens during the loading response and the terminal propulsion phase. When the force is below the body weight line, the body mass is decelerating, and it happens during the single support phase. Also in the sport world, BTS P6000 can support the biomechanical evaluation of the lower limbs, providing useful data to the performance analysis, the injury risk prevention, and athlete rehabilitation. In many sport applications, some movements, such as jumps during the push-off or landing phase, produce very high impact pulses with a very high frequency content in the force signal. In order to have a good response of the platform to this strong mechanical stress, the platform must be characterized by a very high value of the particular parameter called natural frequency. BTS P6000 has been also developed with a more sturdy mechanical engineering, and this new design allowed also to increase its value of natural frequency. This is another fundamental reason that leads this platform to be highly recommended into the sport field thanks to its elevated performance. In conclusion, we can summarize some of the most important technical features of the BTS P6000. The interface is made by Ethernet LAN. The signal output is completely digital. The weight and the dimension of the single module, equivalent to one traditional plate, are 28 kilograms with a sensitive area of 60 per 30 centimeters and a minimum height of 5.7 centimeters. Based on the type of application, it's possible to set the capacity of each sensor. For the X and Y component, the range starts from plus/minus 100 up to plus/minus 2000 Newton. For the Z vertical component, the range starts from 0 up to 2000 Newton. The resolution is 16-bit and the amplifier is directly built in.